Hi, my name is Daniel Alejandro Lopez Montiel, and today I'll be presenting our work for the Edge Impulse AI Hackathon of this year, which is focusing on industrial defect classifier. So me and my brother are focusing on leveraging the Edge Impulse tools to develop a resource-efficient visual inspection model on the Raspberry Pi Pico W embedded device, or microcontroller in this case. So our project focuses in the following. We are trying to demonstrate that this platform, as well as devices that are resource constrained, such as the Raspberry Pi Pico, can be used for different tasks, such as industrial defect detection or classification in this case. So we're using this platform to develop a machine learning model, in this case a CNN, that is capable of detecting defects, maybe mistakes that occur in the production line, as well as other occurrences that may take place, and avoid issues that come when mass producing chips, boards, and other industrial products. So what we're trying to do here is just do a very simple end-to-end workflow, which is basic in machine learning and deep learning, working with data acquisition, feature engineering, model training, and deployment. In this case, the issue would be to develop a very low resource model. Initially, we had thought about developing a vision transformer model. However, due to some constraints in the environment that Edge Impulse, the platform of Edge Impulse provides, we were not able to fully deploy the vision transformer due to some of the conversions of the libraries and operations that are necessary for the vision transformer tools. So in this case, we pivoted to developing a regular classical CNN, but an ultra efficient one, meaning that we're trying to deploy this CNN to do classification and detection and other computer vision tasks to do defect identification. So in this case, we're trying to develop through very efficient operations and layer construction of the architecture of the CNN, this very efficient CNN model for this problem. The results that we're trying to obtain are constraint driven here, meaning that we're working with a very limited hardware, as I mentioned, the Raspberry Pi Pico W, and we're also working with Python libraries, but we also want to implement the Edge Impulse platform. In this case, this implementation, once deployed in the Raspberry Pi Pico, it's going to be transported to the platform. And these are some of the metrics that we're aiming to address, such as inference time. In this case, we're aiming for real-time inference, as well as low memory usage. In this case, the Raspberry Pico has very low memory, as well as very low flash space, so we have to address those and consider them when developing the CNN. And in this case, due to just the task being classification, we're just going to be working with accuracy, but we'll also consider down the line more different classification metrics, such as F1 score, sensitivity, depending on the task. And once we move on to other computer vision tasks, such as detection and image segmentation, object segmentation, for instance, we would consider other metrics according to those tasks. For now, we've been working with a proof of concept experiment in which we worked with fruit identification just to test our results with our model. And in this case, what we got is that we were able to attain an accuracy of around 50 to 60%, depending on the number of epochs that we want to train our model. And we were also able to attain around 1600 FPS, as well as a latency of 0.62 milliseconds and a total of just around 0.85 floating operations per second. So this means that even though the model is not maybe as optimized or as thoroughly trained as some other models that might be used in the state of the art for this task, This is definitely more efficient in terms of frames per second, as well as floating operations, and even the total memory consumption and disk space consumption is also optimized in this case. And these are some of the other things that we have to consider, such as the design that I mentioned and the deployment options once we move on from the Python implementation to the hardware implementation, and the later down the line on the Edge Impulse. And what I mentioned at the beginning, right? We're trying to do an ultra low cost and low power microcontroller that is capable of solving this task, but also other tasks, not only defect identification, but once we're able to develop models that are capable of conducting difficult tasks for computer vision or other machine learning tasks, we're going to be able to use them in other fields, such as healthcare, for instance, and security, surveillance, other things that might require resource constrained models. And finally, like I mentioned, some of the benefits that we can get are cost savings and improved throughput and scalability, that we're able to mass produce with relatively low cost these models and these microcontrollers that are capable of solving these tasks. Things as and a future enhancements that we have to do down the line, as SCADA integration, broader application. And as I mentioned, once we're able to do more computer vision tasks such as detection and image segmentation, that's what we're going to focus on with this project. And finally, just how much of an impact tiny machine learning can have on the big industry, right? We can help in quality control, as well as demonstrating that AI applications can help in production and reduce costs, as well as help in other fields. Thank you very much for your consideration for this application, and I hope to hear your response. Thank you.